I welcome you all to today's Physics Medicine online tutorial class. I remain your physics tutor, Mrs. Okuma. Today, we want to look at the reflection of light at curved mirrors. Reflection of light at curved mirrors. Now, previously we've talked about reflection of light at plane mirror surfaces. And in our last class, we found out that multiple images can be formed on a plane mirror when two mirrors are inclined to a particular angle. And we find out that we can find the number of images by using our formula n equals 360 over theta minus 1. We equally saw the effect of mirror rotation on a reflected ray when the incident ray is fixed. We find out that on a fixed incident ray, if the mirror is rotated to a particular angle theta, that the reflected ray will be rotated through an angle 2 theta. We equally saw the uses and applications of plane mirror, where we can apply it or use it we use it as our looking mirror, we use it as driving mirror. We apply it in the formation of periscope, where the two plane mirrors will be inclined at an angle of 45 degrees. We can equally use it in the construction of kaleidoscope, where the mirrors are inclined at an angle of 60 degrees. Now today, we are studying the reflection of light at curved mirrors, meaning that light can equally be reflected on a curved mirror, not only on a plane mirror. Now let's look at our specific objectives. Number 1, students will be able to mention the two types of curved mirrors. 2, mention and define the essential parts of the spherical mirror, such as the aperture, the pole, the center of curvature, and others. Thirdly, they should distinguish between real and virtual focus of a curved mirror. Now, reflection of light at curved or spherical mirror. You can call it curved mirror. It can be called spherical mirror. Now, apart from plane mirrors, curved mirrors also reflect light incident on them. We have two types of curved mirrors. We have the convex mirror and the concave mirror. The convex mirror, we call it the converging mirror, while the concave mirror, we call it the converging mirror. Remember, I said there are two types of curved mirrors. What are they? The convex or the diverging mirror, the concave, or you call it the converging mirror. Now, they are made by severing a glass surface which is part of a sphere, just like your plane mirror, a glass that is coated at one of the sides using a silvery surface. To coat it, you form your mirror. The same thing, the spherical or the curved mirror, they are made by severing a glass surface which is part of a sphere. Now, if the inside of this spherical part is the silvered part and the outside surface is the reflecting part, the resulting mirror, we call it the convex or diverging mirror. Take note again, I said that if the inside of that spherical part is the silvered and the outside surface is the reflecting part, that mirror becomes your convex mirror. Now look at this diagram. Look at this diagram for the convex mirror. The outer part is the reflecting part. Now look at this convex mirror. You can see the reflecting part. The outer part here is shaded with blue. This outer part is the reflecting part, Why this inside part or the inner part labeled hard surface is the silvery part. The outer part for a convex mirror, the outer part is the silvered surface, while the inner part is the reflecting surface. Then for your concave mirror, we said if the outside surface is silvered and the inside surface is the reflecting part, the resulting mirror is your concave or what? Converging mirror. Take it again. If the outside surface is the silvered, and the inside surface is the reflecting part, you are talking about the concave mirror. So in a concave mirror, the inside surface is the reflecting part. So look at your concave mirror. Look at the inside surface with blue. The inside surface, that is the reflecting surface, while the outside surface is the silvered surface. They label it hard surface. So, but here for your convex, the outside surface is the reflecting part, while the inside surface is the silvery part. Please take note of that. Now, we go over to the essential parts of spherical mirror. You want to look at the parts that make up these spherical mirrors. Number one, we have the aperture. The aperture is the width, AB, of the mirror. Now, when you look at this mirror here, you have your convex mirror. Here you have your concave mirror. For your concave mirror, you find that the reflecting part is the inside part for your concave mirror. So when you look at the aperture, we say it is the length what? AB. The length AB of the mirror. So this is your A, this is your B. So the length from A to B, that is the aperture. Then we have another essential part of this spherical mirror, the pole. The pole is the center of the reflecting surface of the curved mirror. Now let's see the center of the reflecting surface of the curved mirror. Now remember the reflecting surface. Now look at your concave mirror. The inside part is the reflecting part. Now the center of it is labeled what? P. So this center P of the reflecting part is your pole. Now let's look at the convex mirror. Look at your convex mirror. The outer part is the reflecting part for your convex mirror. Now look at the reflecting part, the outer part. So you can see the pole P at the center of the reflecting part of the mirror. Then another essential part of this mirror, you have the center of curvature, C. The center of curvature is the center of sphere of which the mirror forms a part. The center of the sphere of which the mirror forms a part. Now let's look at this concave mirror. If you look at this concave mirror now, this diagram is representing parts of the sphere. Now when you draw it complete, you can have your sphere like this. So the center of the sphere here is your center of curvature. Now let's look at this. Another concave mirror here. When you draw it as a sphere, you can see it will go this way. So the center of that sphere is your what? Center of what? Curvature. That is your center of what? Curvature. The same thing for the other one, the convex. The center of the sphere, when you complete it, the center of the sphere is your center of what? Curvature. Now let's see another part. You have the radius of curvature. you have the radius of what? Curvature. Now the radius of curvature, we represent it with small letter r, is the distance CP. It is the radius of the sphere of which the mirror forms a part. We say it is the distance what? CP. Now let's see. This is our P, the pole, and this is our C. So the distance from here, C, the center of curvature, to the pole gives you your radius of what? Curvature, R. So we say it is the distance CP and it is the radius of the sphere of which the mirror forms a part. Now we look at another one. Another essential part of this curved mirror, you have your principal axis. Let's say it, the principal axis. Now this principal axis is the line PC from pole to the center of curvature. It is the line PC from pole to the center of what? Curvature. From pole to the center of what? Curvature. So let's see the line. It's talking about the line. Remember the radius of curvature, we say it is the distance CP. But the principal axis, we say it is the line PC from pole to the center of curvature. So this line, let's see. This line from the pole, the straight line, not the distance now. The straight line from the pole to the center of curvature is your principal axis. Let's see for the convex. From the pole, that line, straight line, to the center of curvature, that is your principal axis. Look at it here. This line represents your principal axis. Look at the line. So that is your principal what? Axis. Now, we have that when parallel rays of light close to and parallel to the principal axis are incident on a concave mirror, they do what? Converge or come together after reflection to a point F on the principal axis, called the principal focus. We say that when parallel rays of light that are close and parallel to the principal axis, when they are incident on a concave mirror, they will do what? They will converge. And when they converge, after reflection to a point F on the principal axis. So they converge at a point F. And that point F, we call it the principal focus. So the principal focus is the point where these rays that are parallel and close to the principal axis converge afterward reflection. We're going to see the diagram. Then, by contrast, when such rays are incident on a convex mirror, they do what? They diverge. They do what? They diverge. But if it is on a concave mirror, they will converge. They diverge from the surface and appear to come from the point F on the principal axis behind the mirror. Behind the mirror. Now let's see the diagram of what we are talking about. Now look at your principal axis. Remember we said it is the line what? CP. So this line now is the line for your principal axis for a concave mirror. For convex mirror, look at the line for your principal axis. And we say that when rays that are parallel and close to the principal axis, remember a ray of light, a straight line with an arrow head. So this parallel ray, look at this, 1, 2. Now this one is your principal axis, this line. Then this is another ray, 3 and what? 4. Now when these rays, when they are incident on this concave mirror, what will they do? They will do what? Reflect. So look at the reflected ray. Another parallel ray to the principal axis getting incident on the mirror will equally do what? Reflect. Can you see the points? They will reflect. Then you have another parallel ray of light. Look at the third one. On getting to this mirror, they will equally do what? Reflect. You can see the arrow showing they are reflected rays. Another one being incident on this curved mirror, the concave mirror, we equally do what? Reflect. And this reflected ray, they converge at a point, and this point is where we call the what? The principal focus. We label it with capital letter F, the principal what? Focus. So they converge at a point, or they meet at a point called the principal focus. Now for the other one, which is the convex or the diverging mirror, look at your principal axis, this straight line, the line CP. Now look at the parallel rays of light, 1, 2, 3 and what? 4 incident ray of light that are parallel to the principal axis. On being incident on the mirror, they will do what? Diverge. You can see the reflected rays, they diverge. Look at the second ray. Getting to the mirror, we do what? Diverge. Look at the third one. This line is for your principal axis. Look at the third ray. Getting to the mirror, diverges. The fourth ray, getting to the mirror, equally does what? Diverges. So you find out that these reflected rays, they do what? They diverge. But when you trace it back, you can see what is happening now. When you trace it back, they meet at a point. So they appear to meet at a point called the principal focus. Now what are we seeing from this diagram? You find out that the principal focus for a concave or converging mirror, it has a real focus. It has what? A real focus, meaning that you can obtain the image on a screen. You can obtain the image at a particular point on a screen. You're going to see that now. But for a convex or diverging mirror, the what? The images, they appear, the reflected ray, they appear to meet at a point. So this reflected ray is not the real reflected ray, they are apparent. So this image has a what? A virtual focus. So for a convex mirror or diverging mirror, it has a virtual what? Focus. Now let's define the principal focus. Having explained the principal focus both for concave and convex mirror, let's define it. The principal focus of a curved mirror is that point on the principal axis to which incident rays parallel and close to the principal axis converge, or from which they appear to diverge afterward reflection. Now the principal focus of a concave mirror is said to be what? A real focus. As I've told you, they are real focus because the reflected rays actually pass through it. This point of convergence can actually be obtained on a screen placed in front of the mirror as a bright spot of what? Light. So you can see it as a bright spot of light on your what? Screen, showing they have real focus. Now on the contrary, the principal focus of a convex mirror is what? A virtual focus. Is what? A virtual focus. Why? Because the reflected ray do not actually pass through it. As we saw in this diagram, the reflected rays, they did not pass through it. The reflected rays diverges. But when you now trace them back, that is their virtual, you can see they meet at a point. So we said because the reflected rays do not actually pass through it, then if we place it on a screen behind the convex mirror, no bright spot of light or image of an object is seen on the screen. Now let's finish the terms. We will see this real focus and virtual focus. Another essential part of the mirror, finally, is your focal length, F. The focal length of a curved mirror is the distance FP from the principal focus to the pole. It is what? The distance FP from the principal focus to the pole. Let's see from our diagram. We say it is the distance what? FP. So let's see the distance FP for your converging mirror or concave mirror. The distance FP. So look at the distance. Your F, the principal focus, and your P, the pole, gives you the what? The focal length. Meaning that focal length is half of the what? The radius of curvature. Because from C to P, the distance, we call it radius of what? Curvature. Now the distance now, FP, we call it what? The principal, we call it the focal length. So we say that the focal length is the distance FP from the principal focus to the pole. Now experimentally and also by geometry, it is found to be equal to half of what? The radius of curvature, as I've shown you in the diagram. It is equal to the half of radius of what? Curvature for both types of mirror, whether concave mirror or convex mirror. Now, the principal focus is the midway between the pole and the center of what? Curvature. So from the diagram, you find out that your F will be equals to what? R over 2. Your F will be equals to what? R over 2. Meaning that your FP will be equals to what? FC. FP will be equals to what? FC. Now, let's look at this. Now, this is your ray box. You can see your ray box as the object. You see the screen. You can see your mirror holder. Now, you can see your curved mirror, the concave and the convex. Now, let's see. Now, this is your meter rule. Now, look at it. The concave mirror. The concave mirror, it has a real focus. Now, let's observe this. We place it in our mirror holder. Now, look at it. Can you see the bright spot of light on the screen? Showing it has what? A real focus. Now, look at your convex. Now, let's see the convex. Place it on your mirror holder. Can you observe anything? There is no spot of light on the screen, showing it has what? A visual focus. Let's see the concave again. Can you see the bright spot of light? Very good. Yes, showing it has a real focus. So the image from here can be obtained on a screen. The image can be obtained on a screen. When you measure the distance from this object, the ray box, to your screen, that is the object distance. The distance from the object, the ray box, to the screen will give you the object distance. We are going to see it in the next class. From the ray box to the screen gives you object distance. Then from the mirror, that is where you got the image, to the screen, we give you V, your image distance. So you can see that you can get your object distance and your image distance. So you can find out that the image formed by a concave mirror, you can get it on a screen. You can see the bright spot of light for a concave mirror, and that is why we say it has a real focus. But for a convex mirror, as we saw it from our video, it does not have what? A real focus. Now you are going to evaluate yourself. Number 1, evaluation. You mention the 2 types of curved mirrors. Secondly, what is meant by A, the radius of curvature, B, the center of curvature. Then thirdly, distinguish between real focus and visual focus. This is focus and visual focus of a curved mirror. Thank you once again for participating. I remain your teacher, Mrs. Okuma I. Thank you.